Now we're going to discover a really beautiful property of the triangle. The sum of the angles of any triangle is 180 degrees. So in this triangle, you can see that I've marked the angles alpha, beta, and gamma. So I claim that alpha plus beta plus gamma equals 180 degrees. To prove this statement, I'm going to draw this line which passes through this vertex of the triangle and is parallel to this side. And now, from this line parallel to this line, we get that this angle equals this angle. And from this line parallel to this line, we get that this angle equals this angle. But we know that this here is a straight line, and therefore this whole angle must be the straight angle 180 degrees. And here we have it. Alpha plus beta plus gamma equals 180 degrees. From here, when we divide both sides by 2, we can get that alpha over 2 plus beta over 2 plus gamma over 2 equals 90 degrees. Or in other words, 90 minus gamma over 2 equals alpha over 2 plus beta over 2. This can be visualized like that. In a right angle, you can fit alpha over 2, beta over 2, and gamma over 2. Here's how the proof looks like when one of the angles, in this case alpha, is obtuse. You can see that it's completely analogous. Here, I'm going to show you one more way in which you can prove that alpha plus beta plus gamma is 180 degrees. You can see that the green line lies on top of the base of the triangle. Now I'm going to rotate that green line at an angle beta. Now the green line is aligned with another side of the triangle. And now I'm going to rotate it gamma more in the same direction. Now it's aligned to a yet different side of the triangle. And finally, I'm going to rotate it alpha more. After the final rotation, the line is right back from where it started. We essentially flipped the line, and so the total amount of rotation on that line was 180 degrees. But it is also beta plus gamma plus alpha, because these are the three parts of the rotation. And therefore, alpha plus beta plus gamma must equal 180 degrees. The optional problem is find the sum of the angles of an arbitrary 2019 gon. And first, let's clarify what does that mean, 2019 gon. Well, that is just a shape with 2019 sides, such as this one. This is side number 1, side number 2, side number 3, side number 4, and so on and so on and so on, until we get to side 2018 and side 2019. And here's the solution. For a triangle, we know that the sum of the angles is 180 degrees, which we're going to write as 1 times 180. For a quadrilateral, you see that the sum of the angles of this triangle and the sum of the angles of this triangle added together equals the sum of the angles of the whole quadrilateral. And therefore, the sum of the angles in the quadrilateral is 180 from this triangle plus 180 more from this triangle, which makes 2 times 180. For a pentagon, we can split it into a triangle and a quadrilateral. For the quadrilateral, we know that the sum of the angles is 2 times 180 degrees. And for the triangle, we know that the sum of the angles is 180 degrees. And the sum of the angles of this triangle and this quadrilateral makes the sum of the angles in the entire pentagon. And therefore, the sum of the angles of the pentagon is 3 times 180 degrees. We can apply the same thing for a hexagon. A hexagon can be split into a pentagon and a triangle. The pentagon has sum of the angles 3 times 180, and the triangle has 180. And so the sum of the angles in a hexagon would be 4 times 180. Do you see the pattern? Each time we add a new vertex to get from an n-gon to n plus 1 gon, we can split it into a triangle and an n-gon. And so we just need to add 180 more to the previous sum of angles. So for an arbitrary n-gon, the sum of the angles is always n minus 2 times 180. So for a 2019 gon, the sum of the angles would be 2017 times 180.